Hello, everybody. This is Derek Demeter, the Planetarium Director at the M.O. Buehler Planetarium at Seminole State College. And of course, joining me today is my colleague.
Hey, it's Justin Cirillo. How's everyone doing tonight, today, wherever you're at? Welcome.
Exactly. It could be anywhere. And we might even have some interplanetary viewers. I don't know.
Ooh, I
You
didn't even
never
think of
know.
that. You're right.
But tonight we're going to be exploring what you can see up in the sky. Of course, this is for September of 2020. But of course, the sky will be very similar to what you would see around this time of year. The planets may change, and a few other objects may be visible, not be visible. The moon, for example. But the constellations will be relatively in the same position. So if you're watching this on another, next year or the year after that, around this time of year in September, this is pretty much what you would see, except for the position of the planets and the moon. Now, what we're also going to be doing in today's episode is we're going to be exploring what's new in space exploration. So Justin's going to be covering that. And of course, for those that are watching on Facebook, if you have any comments or questions, Justin will be watching that. And answering those questions for you, or if you have any questions specifically for one of us to answer on the video, just go ahead and Justin let us know, and we'll do our best to answer those questions. So, again, what we're going to do first is we're going to be doing a little presentation we call Central Florida Nights. This is our tour of the night sky. So again, as I mentioned before, the skies, what you're going to see will be pretty much the same, except for the position of the planets and the moon. Those do change as the planets go around the sun, as the moon goes around the earth. The position of those planets and the moon will change depending upon where they're located. So the constellations and the stars that we see in this time of year will pretty much stay the same. Now, what I mentioned earlier before we started our recording, for those that are watching that are from different parts of the world, we're going to be looking at the sky seen here from Central Florida. So if you're watching from another location around the world, the sky is going to look a little different to you. If you're in the Southern Hemisphere, you might see a completely different type of sky, but some of the constellations that you'll learn tonight might be visible. So take what we look at today and try to apply that to the location you're at. If you're in the northern latitude, say you're in Alaska or Canada, the position of these constellations may be shifted quite a bit. So keep that in mind when you're looking at the night sky. Depending on where you're located on the globe will depend on how the stars will look. But if you're close enough to Florida, or if you live here in Central Florida watching this video, this is pretty much what you're going to see tonight. Now, I have the sky set to about 9 o'clock this evening. Now, the best part of the fact is we're getting closer to the fall equinox. Now, equinox literally means equal night. So what's happening is as the Earth is traveling in its orbit around the sun, the axis that our Earth basically rotates around essentially is now facing in such a way where we have equal day and equal night. So our nights are growing a little bit longer, and our days are growing shorter. You notice, of course, summer, the days have been very long, but now they're slowly getting shorter. The sun is setting earlier and earlier and earlier, and eventually we're going to get to a point around September 21st, 22nd, where essentially the daytime and nighttime are pretty much equal. So the nice thing is that we don't have to wait as long to actually go outside and see the stars, which is really exciting for us astronomers. Wouldn't you say, Justin? It's kind of nice to have that daytime stuff for us to do some fun activities, but it is nice not to have to wait till really late just to actually look at the sky.
Oh yeah, if you're an astronomer, yeah, you really look forward to the fall, the daylight saving changes. I can't wait for November.
Oh, yes. Now, of course, we're starting our virtual public shows right now. However, we have a really exciting upgrade for the planetarium. You might remember Frank Kane, our partner in crime when it comes to this virtual star parties. Well, we got a system that's pretty much almost similar to Frank's. So now we're going to have double the telescopes during our virtual star parties. And we're looking at starting those in October when we get away from the height of the hurricane season, when hopefully the skies start to clear up and it's going to get a little bit darker, cooler, less bugs, and less humidity. And we'll be able to actually set up our telescopes and show you the wonders of the universe. And we're going to be doing things a little bit different this time. Normally we would do a public show on Thursday, and then a virtual show, or excuse me, a virtual star party on Friday. What we're going to be doing now is we're going to be doing virtual public shows and star parties on Friday nights and alternating between the two. So we'll do one public show on Friday and then a virtual star party on another. Now, of course, if the weather's crummy and we can't actually look at the sky, we'll substitute and we'll do things like that accordingly. But we're hoping to kind of alternate between the two so that way we can give you all some really cool experiences for the fall. And we got some really exciting shows. We'll talk about more of those later on in the program. So let's go ahead and get started with our tour of the night sky. What I'm going to do here is I'm going to go ahead and share my screen. So as you can see, Justin, can you verify that you can see my stellarium right now?
Looks good. Looks good.
All right, fantastic. So let me show you all a little bit of our information about tonight. So again, we have here, it is September 11th, 2020. Of course, that's today. And we're looking at about almost 9:30. I'm going to go ahead and shift this back over to 9 o'clock. Again, as I said, nice thing about getting a little bit later in the year is we don't have to worry about waiting till very late in the night to actually see the stars. Now, one of the things that we're going to notice right at after sunset is we're going to be looking towards the south. Now, one of the things that we have these different markers down here. We call these cardinal points. So we have south right here. We have the direction of west over here. And if we continue over here, we eventually get to the direction of north. Now, people have asked me, well, how do you know your directions? Well, one of the things you can use is you can use a compass. And essentially, you want to point your compass towards north. And that gives you a general idea of which directions. Now, of course, there are two different types of positions. There's geomagnetic and there's actual true north. Geomagnetic is actually shifted by a little bit, so you're actually not going to be looking directly north if you're using an actual magnetic compass. But in the sake of tonight's program, it's pretty close. But if you know how to find north, the first thing you want to do is using your compass, you want to go ahead and find north. You're going to see over here on the what we call the horizon. The horizon is essentially the bottom of the sky, the lowest part of the sky, where the sky and the land meet. We're going to see 7 bright stars. You can see these 7 bright stars here. And for those that are watching and live, if you know the answer to this, we'll give you a few moments to answer if you're watching. Let me know if you know an answer to the name of this object. Now, this object is actually named two different. One's an official name and one's a non-official name, but a lot of people know this object by its non-official name. So if you know the answer, go ahead and leave a comment. So Justin, let me know. We'll reveal the name of this object in a few moments. So if we have an answer, Justin, in the comment section, let me know, all right?
All right, I'll chime in.
So I'm going to hold off on revealing the name of this object here, but what we're going to do is we're going to find these 7 stars, and we're going to take the 2 bottom stars of this object, and we're going to go ahead and point over towards the north, and we'll find this fairly relatively bright star. And this right here is the star Polaris. If you know the name of the common name of Polaris, it's the North Star. And you can see that Polaris is basically right over the direction of north. Now, why is that? Well, the reason for that is, again, going back to the Earth. The Earth rotates around this, what we call axis of rotation. And essentially, the North Pole, or in this case, the axis, is pointed basically straight at the North Star. So as the Earth spins, and what I can do here is I actually can speed up time. You can see that
we've got some answers here, Derek. You ready?
We do? Excellent. All right. Well, I'm gonna go back to 9 o'clock, and you can see that the constellations surrounding the star move, but this star doesn't. It's always fixed. Technically, it does move a little bit, but to our human eye, we don't really see it. Now, Justin, what's the name of this object over here? What do we got?
Well, we had Amber chime in first. I'm assuming Zoe's a girl, 10 years old, said the Big Dipper. And we got a bunch of answers saying Big Dipper, and a couple said Ursa Major, which is
well, you would both be correct.
Right?
Yeah, both of those answers are correct. See, the Big Dipper is what we call the asterism found here. An asterism is an unofficial picture of stars made by patterns of stars. And Ursa Major, the Big Bear, is actually the main official constellation found here. So here we have the 3 stars of the handle and 4 stars for the cup. That's the Big Dipper. But actually, the rest of the bear is starting to move below the horizon this time of year. Actually, several Native American people actually had stories talking about hunters hunting a bear, and the bear eventually travels below the horizon to, or very close to the horizon, depending on where the story was told. And there's actually a legend, and very serious legend, series of legends that actually talk about the motion of the Big Dipper. And a lot of cultures around the world actually saw this as a bear, which is actually really, really cool. Now, again, here we have, this is actually the body of the bear. Here we have the 3 stars of the tail of the bear. Now, again, going back to Polaris, Polaris actually makes up the main star of the Little Dipper, or the Little Bear right here. We have the 3 stars of the handle and 4 stars for the cup. Now, the Little Dipper is not as bright as the Big Dipper. So if you're in a very light polluted area, you probably won't see these stars here because they are very, very dim. You might only see these 2 stars and Polaris. But if you know how to find Polaris, now you're able to know your directions. So if you're standing in front of Polaris, you look down towards north, if you look to your right, you look over your right shoulder, you head over to east. Behind you, facing north, we move to south. And if you were to look at north and you tilt your head over to the left, you'd be facing west. So if you're looking towards north and you go in a clockwise direction, starting looking at north, to your right, behind you, and to your left, if you remember, never eat soggy waffles, or never eat sour worms, or anything else that you may not want to eat that begins with the letter S or W. So you can insert there. Now, I actually like soggy waffles. I'm a weird person. I like soggy waffles. I like it where it's just covered in syrup. And anyways, that's just me personally. But we're going to go ahead and look towards the south. So as you can see here in my image here, we're looking towards south. And what we're going to notice up here, just about halfway up in the sky, we're going to see these 2 bright objects. Now, we have a little bit of a clue here because we can see them named already. We have the planets Jupiter and the planet Saturn. Yeah. Now, how do you know the difference between a planet or a star? If you know the answer to how you know the difference between a planet or a star, leave a comment in the chat. And Justin, let me know who gets it. If you know gets it right, let me know. Then we're gonna try to make this a little bit more interactive for our viewers. If you know the answer to this question, how you know the difference between a star and a planet, leave that in the chat, so that way we know. And Justin, let me know who gets it right, and hopefully we'll get some answers very soon.
We'll get some answers here in a second. It's been so neat watching these 2 planets over the past 2 months. In the sky, and now they're at this point in the sky where they almost, you look up at night and they just look like eyes looking down on you.
That's right.
Pretty cool.
And not too long ago, the moon was very close to Jupiter and Saturn as it travels around the Earth. And just recently, Mars and the moon were very close together. And we'll talk about Mars a little bit later on, how to see it. So what we're going to do is we're going to go ahead.
Lewis said stars twinkle, Derek.
Oh, right. Lewis, you said that was the name?
Yeah.
All right, Lewis, you are right.
In too. Yep.
Lewis, you are right.
Stephanie.
Yes. Planets don't twinkle. Stars do. And that's because the light from the stars are traveling very far away and they're interfering by the atmosphere. Planets are much brighter. You don't really see the atmospheric effect from that light coming from those planets. So the stars will twinkle, the planets won't. And the worse the atmosphere is kind of like a wave, like the ocean, kind of like a waviness. Circulations of air and all kinds of currents of air flowing through in the atmosphere. The rougher the atmosphere is, the more the stars twinkle. And the less rough the atmosphere is, the less stars twinkle. So we astronomers like when stars don't twinkle a lot. because it means the air is calm, and it gives us nice pinpoint stars when we observe objects in the sky. Now,
So when you were doing astronomy in Atacama, what did they twinkle at all, or was it very, very, I don't know?
oh, it was. Oh, yes. So the question is that in the Atacama, which is one of the actually is the driest place on Earth, and at very high altitude, and very good seeing. The stars were very pinpoint out there. Pretty much almost no twinkling. So there are places you can go in the world, like in South America and Chile, where you can go and see stars that are very, very crisp, which is really cool. All right, we're going to go ahead and center on Jupiter. We're going to go ahead and zoom in on Jupiter. Now, eventually, we're going to be able to do some observations of Jupiter in the future. We're going to be setting up telescopes for us to observe these planets on another night. So hopefully we'll be able to do that soon. As you can see here, when we look at Jupiter through a telescope, this is kind of what you would see in a mid-sized telescope. If you have a smaller telescope, you might see something like this. But you would still notice almost the planet Jupiter has this stripy pattern to it. And those stripes are actually layers of clouds in the atmosphere of Jupiter that are swirling around. Because, see, Jupiter rotates incredibly fast. Of course, one rotation of Earth is 24 hours. One rotation of Jupiter is under 10 hours long. So since it rotates so fast, it's about 1,000 times the size of Earth, this creates a lot of churning motion, and we call the Coriolis effect, this churning of air and gas and layers in the atmosphere, and that creates these really cool striations or stripes found, layers of clouds found on Jupiter. But if
Can you zoom in a little more, Derek? There we go.
I was just showing
Yeah.
everybody kind of what it looked like in a small telescope. But when you have a more advanced telescope, you would see a lot more detail. And when the seeing or the quality atmosphere is very good, when the atmosphere is nice and still, you'll be able to see these tiny little storms in the atmosphere. You'll actually see more. Now, sometimes when you look at Jupiter, you might see these dark spots. It almost looks like there's a hole on Jupiter, but what you're actually seeing is a shadow casted from one of the moons of Jupiter. In this case, we're looking at Europa, which is a very cool moon of Jupiter. It has we think that has a just underneath the crust a mantle of water that could potentially have life on it. This is actually casting a shadow on the planet. And sometimes you can actually you'll see these shadows move, and you'll see other moons go in front of it or behind it. It's really cool. In fact, Galileo actually used Jupiter as a way to prove that the Earth was not in the center of the solar system. It was the sun, because he noticed that these moons like Ganymede, Io, Callisto, which is actually, I believe, behind Jupiter right now, and Europa actually went around the planet. And you can actually see that motion over time. If you kept looking at Jupiter hour after hour after hour, you actually see these objects move around. You even see the planet Jupiter change. Eventually, you might be able to see the Great Red Spot, which is this large weather system found on Jupiter. So hopefully we'll be able to take a look at Jupiter through a telescope in the future. And oh, there's Callisto. Callisto's way back here, so that's why we couldn't see it earlier. All right, so we're going to go ahead and leave Jupiter now, and we're going to go ahead and visit the next door neighbor, Saturn. Now, Justin, can you attest that Saturn looking through a telescope is really cool?
Yes, I mean, my first telescope was not a very large scope. It was just a small 3.5-inch lens. And, in the telescope world, that's not very big. And even with that beginner scope, this is exactly what I could see. Now, there wasn't the color detail that you're seeing here, but you could make out the rings beautifully. You could make out the Cassini division in the rings. You could see the shadow of Saturn on the rings. So even in a small telescope, Saturn it's breathtaking, and it's fun when we do outreach events, because when we show this to people, they can't believe it's real. They think it's just a sticker on the end of the telescope, right? That we're kind of tricking them somehow. But it is just fantastic to look at, an object that is almost 1 billion miles away.
Exactly. And what Justin was talking about was this Cassini division. The rings of Saturn are not solid. They're not, it's not like a frisbee or a disc surrounding Saturn. They're actually made up of billions of tiny little chunks of ice and rock that are being suspended and held by the gravity of Saturn. And different little shepherd moons actually are found inside the rings that actually, using their gravity, kind of herd the rocks and ice into place. And some areas have more gaps than others. In this case, we have the Cassini division, which is this large gap in the rings of Saturn. And the rings are incredibly thin. They're only 1,000 feet or so thick, but they're over 270,000 miles wide. So they're very thin, but they're very wide. So you would be able to fly through the rings really, really, really quickly if you're going from top to bottom or bottom to top. But so Saturn is also a very large planet. And if you look at Saturn again, you would be able to see this view. And many of the moons of Saturn, like Tethys and Mimas, which is, I think, one of your favorite moons, right, Justin? The one that looks like the Death Star, has this large crater called Herschel crater that looks exactly like the Death Star, Death Laser crater, if you will. There's Titan, which is one of my favorite moons because it has an atmosphere and it's thought that could have life, has pools of methane and other hydrocarbons. It's a really, really, really cool place. So you can also see Saturn through a telescope, and you can see it with your eyes. If you just go outside tonight and again look towards the south, you'll see both Jupiter and Saturn. All right, so we've taken a look at the planets that you can currently see up in the night sky. What we'll be able to do later on, right at the end of our presentation, is I'll show you where to find Mars, because Mars will be rising later in the night. And we're going to be doing a really exciting viewing event for Mars in October. Now, if we move over to the southwest, you'll see a fairly bright line of stars that kind of looks like a fish hook. In fact, actually, to the people of Oceania, they saw this as Maui's fish hook. So if you enjoy Moana or any of those shows that talk about these people, you might remember Maui's fish hook. But or I also see it kind of look like a top of a like a clothes hanger. This right here is actually the constellation Scorpius, the Scorpion. We can actually put up some pictures here. We can see that marks the head of the Scorpion. We have 2 stars for his claws. We come down here, we have his body, and of course his tail off to the left here with these 2 stinger stars, Lesath and Shula. These stars here make the stinger. So I'm going to go ahead and get rid of the artwork here. Now this bright star here found in Scorpius is called Antares. And Antares literally means not Mars. Now, this is actually important because right now Mars is not up in the sky, but basically when Scorpius is about to set, Mars will rise. So you might go, wow, that's Mars in the sky. We got Jupiter, Saturn, we got Mars. Well, the name gives you away. It's not Mars. So don't mistake this one for Mars and vice versa. So this is a very large star. This is a supergiant star. That's what gives it its red color. It's a star that's starting to fuse heavier elements in its core, starting to, it's gotten bigger but cooler. This is not producing as much energy as it did when it was younger. So a really, really nice, beautiful star to see in the sky. Now, if you are in a darker area of the night sky, let's say you are a place further away from city lights, you might see this cloudy-like area in the sky. This is the Milky Way. Now, the Milky Way, it kind of looks like a cloud, but if you were to use a pair of binoculars and look at this area, you would see billions of stars. So many stars that are compacted together, it makes it look like this cloudy object in the sky. But located just next to Scorpius, if we take his tail, we go up here, we eventually get to this area that kind of looks like, if you look closely, it kind of looks like a teapot. See, you got the top there, here's the handle, here's the kettle. and there's the spout. But this right here is Sagittarius, the centaur. If you know Greek mythology, you remember centaurs are half people, half horses, right? But here we have Sagittarius, and we can see there he's drawing a bow. He's about to shoot it at the scorpion, because the scorpion is chasing after Orion in the sky. And of course, you can't see Orion this time of year. You got to wait till later in the year to see Orion at this time of day. Now, located in Sagittarius, just above the spout, where we would then imagine steam coming from, this area of the galaxy is known as the center. Over here is called Sagittarius A star. We can't physically see it with our eyes, but Sagittarius A star is this supermassive black hole found in the middle of our galaxy. That supermassive black hole has such a massive amount of gravity that's holding all the hundreds of billions of stars in our galaxy together and causing our galaxy to rotate and all that. And it's just really cool you can actually imagine yourself, when you look at the Milky Way, you can kind of see this large area and really feel connected to our cosmos, which is really, really exciting. Now what I want us to do is I want to go ahead and head up towards the top of the sky. We're going to look at what's called the zenith. The zenith is the top of the sky. And what we're going to see near the top of the sky, pretty much look directly overhead, is we're going to see 1, 2, 3 stars. And this, of course, if you connect those 3 stars together, you get the summer triangle. Now here in Florida, our summers are a lot longer than people up north, and this stays around for a little bit longer, so it's technically always still summer in Florida, it feels like sometimes. But what we're going to do is we're going to look at this star, Vega. It's a nice bright star. It's actually a fairly close star to our solar system. It's about 25 light years away. So for a star, that's relatively close to our home. And fun fact, Vega will become the North Star in about 14,000 years from now, because our Earth wobbles around like a top, and the position of the North Pole, the North Pole axis points at different stars. In about 14,000 years or so, Vega will become our North Star. So that's kind of interesting to think about, right? This right here is called lyra. And lyra is a musical instrument. It's called a lyre. I'm not lying about that. It's a lyre. And a lyre is kind of like a small harp-like instrument you pluck and make music out of. And located in this area of the sky is a really cool object that hopefully we get to take a look at in our first virtual star party. It is what we call the Ring Nebula. Justin, you want to talk a little bit about the Ring Nebula?
Well, nebulas are absolutely fantastic. They're technically called planetary nebulas, even though they really have nothing to do with a planet. But what you're seeing here are the remnants, almost the ghost of a dead star. Stars are born and stars live out their lives and stars die. And after this star died, it left these beautiful colors in its wake in the universe, seeding new elements. And so what you're seeing here is the white dwarf remnant of that much larger star, and the elements from the death of that star being thrown out into our universe.
So the colors determine what we're seeing. We have hydrogen, we have oxygen, we have other types of elements that were being produced in this core of this old star that eventually have been deposited out. And what's left over is a compacted carbon star, basically a big ball of carbon that's just slowly breaking down. In about a few million years or so, this white dwarf will basically cease to burn, and it'll become essentially a black dwarf. It would just be this big, dense ball of almost like a charcoal of carbon that's just lingering there. And eventually we won't see the nebula anymore. It will just fade away. So it's kind of nice that we get to see this. But Justin, isn't this kind of looking into the future for our sun?
Oh, absolutely. One of the most common questions we get from kids and even adults is, you know, our star, the sun, is not going to live forever. And once it reaches a certain point, it's going to start to become a little bit more of a helium star than a hydrogen star, and begin to expand so much that it will actually, unfortunately, cook our planet as well as Mercury and Venus to the point where, well, that equilibrium that most stars have that allow them to exist will begin to fail. That equilibrium between outward pressure and gravity, and our sun will essentially look exactly like what we have here. It won't explode into a supernova, but it will leave the remnants of its elements and leave a white dwarf star in its wake.
So that's not going to happen for a very long time for those that are watching. So don't get scared that we're going to be, 2020 has already given us a lot of bad news. The sun is not going away, thankfully. So don't lose sleep over that. So, all right, what we're going to do now is we're going to take a look at our next constellation. So we had Vega here, which is the brightest star in Lyra. Just over here, just below it, we can see the star called Deneb, which literally translates to tail. And this tail belongs to the tail of Cygnus, the swan. We can see here's our swan. We have a couple of wings. We have these stars that kind of make the wings of Cygnus. We have another wing here. We have his body. And just over here at the top of his head is a star called Alberia. Now, unfortunately, Stellarium doesn't do a great job kind of splitting this, but that star right there is actually a binary star. It's a double star. And we like it because one color is blue, one's kind of a goldish color. Now, we're from Seminole State College, go Raiders, and our colors are blue and gold. So we call that the Seminole State Stars, in honor of us. We just coined it. I mean, there is no trademark to the stars, but we're going to go with it because our college likes when we say that, so we go ahead and say it. So there we are. But there's some really cool stuff found in Cygnus. We have supernova remnants. We just talked about a star like our sun that has exploded. Well, when you have a massive giant star that explodes, like say Betelgeuse, you get heavier elements that form in their cores, and you get these massive explosions we call supernovas. And this supernova has basically erupted. It exploded with such violence that you could actually see it in other galaxies. And what's left over is all this material found here that actually over time will eventually condense again and form new stars and planets out of. So the universe, in a way, is its own recycler. The stars explode. The leftover material, which does contain still a lot of hydrogen there, will eventually compress to form new stars. Those stars might not be pure as the other stars are. So like our sun, it contains some other elements in there. But some of those elements will compress and form planets like the Earth, or in this case, our planets in our solar system. So again, these massive giant eruptions into the universe, these supernovas, eventually recycle and form new solar systems. So the things that you love, all the gold, iron, silver, all the stuff found in the iron in our blood, all that is found from dying stars like this one that formed what we call the Veil Nebula. This is called the Veil Nebula, found in Cygnus. This is the witch's broom, which kind of looks like a broomstick. This is the Eastern Veil, and you got all this remnant right here. So we have a star like our sun that died, that created the Ring Nebula, and then we have a high mass star that basically died and formed a supernova remnant.
Veil, my alien nebula.
The Alien Nebula, that's right. It does look like the alien from the movie Aliens. Now, the last star in the triangle is this star called called Altair. And this is the head of our eagle, Aquila, the eagle. And, Justin and I always make the joke that you don't know the seasons in Florida not by the changing of the leaves, but by the birds that travel back to Florida. And right now we're starting to see bald eagles come back to Florida. And that's when we know that the fall is about to come back, or about to start, when we see bald eagles come back to Florida as they get ready for their nesting season. So yeah. So anyways, this is a cool one. You know, we think it always, you know, I always imagine a bald eagle or something. So here we have our eagle's head here. We have one wing here. We have another wing here, and its tail. And because we're in Florida, we got to talk about little Delphinius. Isn't it cute? Look at our little
Oh,
dolphin. He
look
has
at him.
a little head there, a little, you know, dorsal fin and back fin and all that. But anyways, so here again, let me go ahead and get rid of these pictures. It makes it a little bit more difficult to see. And I'm going to go ahead and get rid of the lines, but I'm going to keep the names up still. Again, what you want to do is you want to look towards the top of the sky, and you'll see these 3 bright stars, and those make up the constellations Lyra, Cygnus, and Aquila that make up the summer triangle. So I want all of you to go outside and look for that in the sky, and also be sure to take a look at Scorpius as it's starting to fade away, Sagittarius, Jupiter, and Saturn. And the last thing I want to talk about before we finish up here is if you wait till a little bit later, oops, wrong button. If you wait till a little bit later in the day, or night, I should say, you'll eventually see this red object that isn't twinkling either. This is the planet Mars. Now, Justin, do you want to talk about what's special going on with Mars right now?
Actually, a lot of cool things are going on with Mars right now, but let's see, you're about 11:30 at night Eastern
Yes.
right now. Okay, so, well, Mars is going to be spectacularly brighter than normal. And that's because it's in a position in our solar system where it is the closest to Earth. And therefore, we're going to get a much better view of it. Even without binoculars, even without a telescope, you're going to really notice how bright and red this crimson planet is in the night sky on a clear night. Just it looks fantastic. When you look at it through a telescope, boy, you can really start to see the features of the planet. You can see polar ice caps with a decent telescope. But we're in a point in time right now where Mars is the closest it's going to be to Earth over the course of 2 years. And every 2 years, Earth and Mars get real close to each other, and that happens to coincide when we send spacecraft to Mars. And if you've been following NASA recently, Perseverance just recently launched from Florida. China sent a rover also to Mars. That's on its way to Mars. And the reason why they sent them now is because if they miss that window, you have to wait 2 more years before you can send that spacecraft back to the planet. And luckily, China, as well as NASA, were able to get their spacecraft off the ground, off of Earth, and they are currently traveling to Mars. And you'll be able to enjoy Mars beautifully in the night sky over the next several months. And we'll see those spacecraft landing in early 2021.
Definitely. So Mars is a really cool place. And we want to mention that on October 9th, we are going to be doing a special event. It's the opposition of Mars, or closest to opposition of Mars, the closest weekend to it. And hopefully the skies are clear. We will be able to take a look at Mars using our telescope systems. We'll have several other guests on as well to talk about some really cool facts about Mars, some of the missions to Mars, and of course to observe the planet Mars. So this is a really exciting time for Mars to definitely be able to take a look at that as well. If you stay up a little bit later, you'll be able to observe the planet Mars. So that's what we have tonight going on with our Central Florida nights. I don't want to inundate all of you with a million different constellations, but I want you to go ahead and try to find the summer triangle, planets Jupiter, Saturn, and Mars, and the constellations Scorpius and Sagittarius. And so with that, what we're going to do now is we're going to switch gears. Before we do, though, I want to ask Justin, do we have any questions from the Facebook of anybody regarding the night sky or anything?
Joe Curtis just wanted to clarify the direction of the summer triangle, and I was trying to type it real quick, but if you want to go ahead and relay it.
Yeah, so let me go ahead and share my screen again with Stellarium. So the summer triangle, it doesn't really have a definite direction. It's basically literally right overhead. So all you have to do is literally look straight up. And when you look straight up, you should be able to see the summer triangle. So now it's going to be, I guess it might be shifted a little bit towards the west a little bit. Now we've changed the time. Yeah, we're at 11 right now. So yeah, at 9 o'clock, it's pretty much directly overhead. So all you have to do is look straight up and you will find the summer triangle.
And Vega is definitely the highlight of that. If you get a chance to look at that through a telescope, it looks like a beautiful blue diamond. It's fantastic to see, and it's fun to look at when you're going straight above.
Absolutely. All right. Any more questions, Justin?
Stephen Smith asked about Betelgeuse real quick. He wanted to get an update on the status of, are we going to see this star go supernova anytime soon here, Derek?
Not yet. But what's interesting is we actually have a friend of ours from the Central Florida Astronomical Society. Her name is Barbara Harris. She actually does research on variable stars using alongside the American Astronomical Observation of Variable Stars. And they're noticing that Betelgeuse is starting to dim again. Now, the latest conclusion is that Betelgeuse is shedding a lot of its outer layers. It's kind of getting very unstable, and a lot of that excess gas blocked a lot. It's almost created like a cloud that blocked the light of Betelgeuse for a little bit and dimmed it. We think that it might be doing the same again, but that means that this star is becoming more and more unstable. Now, I don't want to say that it's going to go supernova anytime soon, but the earliest stages of a star starting to kind of show signs of what we call degradation, when the star begins to kind of fall apart and eventually explode, is starting to happen. Betelgeuse is a really exciting object. It's one of the brighter stars in Orion, the Hunter. Now, Orion starts to really rise at a decent time of night. Right now, it is actually visible if you get up around 5 o'clock in the morning. But if you want to see it this time of the day, you got to wait till the winter. But who knows? This is going to be a very exciting time to keep observing Betelgeuse. For those that study variable stars, Betelgeuse is putting on quite a show.
Yeah, absolutely. I'll leave it to 2020 for a supernova, right?
That's right. Definitely. Now, there have been some other supernovas that have been visible in other galaxies. We actually did an episode of our virtual star party where we did observe one. I think it was an M50, or oh man, I can't remember which one we were looking at. I think it was M. Do you remember, Justin? You know which message? Gosh, it'll come to me. I will.
Yeah, because we were looking at so many at the same time.
That's right. Yeah. And I'm sure somebody in the comments will shout it out. So if you remember which one it was, that's the thing I love about doing live programs, is sometimes your brain, you can't remember everything when you're doing something live. But there was a galaxy that we were observing that there was a supernova going off, which was really exciting. All right. So Justin, I'm going to go ahead and turn it over to you because you have some really cool up-to-date information about space exploration in our solar system.
Oh, sure.
So,
yeah.
So I'll let you.
Well, I'm pulling that up. We had a question from Miriam asked about we got that 6-foot asteroid that's going to be coming around Election Day. I know the media were talking about that quite a bit, but wanted to know is that something visible or that would be a tough one to see?
Well, asteroids are always really tough, even for people that know what they're doing, because asteroids look like little tiny stars, and you will see them move over time. Actually, I've done some asteroid imaging where you actually take an exposure every couple of minutes, and you're able to actually see the drifting of the star. But you can see it using a telescope, but it's going to look like a very dim star. But if you know where to look and know the position, and I'm not quite sure exactly where it is at the moment, but while Justin is doing his presentation, I'll look up that information and I'll let all of you know at the end of the program.
All right, excellent. Well, what this part of the show is just talking about some current events that are going on in space exploration. Mainly spacecraft that we are either in the process of missions or going to be sending missions here soon. So we're going to talk about just some of the current events that have happened over the past, probably last 6 months, and what we can expect to see in 2021. This first image here, there we go. Derek, what's going on in this picture? Is it like grain silos coming down from space?
Sure looks like to me, but
I know.
it kind of looks like a tanker or something. Just somebody, maybe somebody filled in some explosive material. Maybe, you know.
That is what's so cool about where we're at with space technology and where we're headed. So what you're looking at here is a flight test of an early prototype of Starship. And this is a SpaceX prototype. And on August 4th, SpaceX ignited this Starship with just a single Raptor engine. And you're just looking at the first stage. So this rocket will eventually absolutely dwarf the current Falcon 9 rockets that are launching astronauts into space right now. It will have 28 Raptor engines at the base of it, and then another 4 on the second stage. But this prototype, they're testing down in Boca Chica, Texas, and the functionality that they're working on is kind of a hop, where they can launch it, move it, hover it, and then land it again very, very quickly. And the next prototype that they're working on, which is called SN8, is currently under construction right now, and that's expected to have 3 Raptor engines, a nose cone, and all kinds of cool aerodynamic surfaces on the rocket. But I want to show you guys where we're at right now with space travel. Check this quick video out. So we're right on the coast of Texas. You can see another launch pad just there to the left, and you can see the original Starhopper there. But this test was to make sure that this Raptor engine could take this booster, move it about, you know, a couple hundred yards, and then land it again. And this SpaceX Starship system, it's a fully reusable 2-stage system, and it's a super heavy lift vehicle. If you've heard of the regular Falcon, you've got a 9-engine spacecraft. The Falcon Heavy is a 27-engine spacecraft. This thing will have 32 engines, and its design is to take heavy lift objects into to the solar system, into the International Space Station, and then eventually to Mars. So this is Elon Musk's kind of early stage of a much, much larger rocket than what we're seeing now, but pretty exciting stuff. And that just happened last month in August. We have another very exciting launch. This is pretty cool if you're a local Floridian. Now, Derek, I know you were trying to get to this launch because you were going to try and get a shot of this kind of with the Milky Way in the background. Do you think you still have a shot of it in September?
Well, the launch right now is looking good. Right now, actually, the gentleman that's featured in this amazing photo and I are going to be getting up early or staying up late and going to attempt this this launch photograph from a special spot to capture a really interesting and cool moment. So stay tuned. Yeah. Hopefully keep our fingers crossed. It will go up
this time. Well, what you're seeing here is an image taken by Cold Life Photography. He's a photographer friend of Derek's, a very talented guy, and he has special permission from Kennedy Space Center and the different launch companies to take these amazing up-close images. So what you're seeing is you're seeing a hot fire abort that happened with, it was pretty much T-3 seconds, and the automated system that takes over, it noticed an issue and aborted the launch, a scrub, and to save the rocket and save the payload. This is a National Reconnaissance satellite that's on board, a very, very expensive multi-billion-dollar satellite for our US government. So the issue ended up being something related to like a critical pneumatic control system, but very, very expensive. And so the system shut down. And this shot is from one of Michael's remote cameras that he had set up on an adjacent launch pad, Launch Complex 34. But if you write this down on your calendar, the current launch date time is September 18th, just a week from now, 12:30 a.m. Eastern. And even if you're not a local Floridian, United Launch Alliance, SpaceX, NASA, they live stream all these events. So no matter where you're at in the United States or even anywhere in the world, tune in and watch these amazing launches. But this is a big, big rocket. So you're looking at literally 3 rockets strapped together with a massive payload on top. So if you're a local Floridian, it's one of the treats of being here in Central Florida is not only Disneyland, but watching these rockets going up. So
Justin,
Derek,
let me add
I hope you get that shot. Yeah.
Let me add something real quick, because I have had a few people ask me in the past. It does create some confusion when you see these late night launches. When it says September 18th at 12:30 a.m., that means basically the evening of September 17th into the morning of the 18th. So you're not going to be watching it you're not going to be watching it on the 18th into 19th. So I just want to let everybody know that it's the morning of the 18th. So so start getting ready the evening of the 17th to watch the launch at 12:30 in the morning on the 18th.
Excellent. Yeah, that's important. That's important. And if you follow these companies like United Launch Alliance on social media, whether it's Instagram, Facebook, or even their web pages, they're very good about giving you updates leading up to the launch and live streaming it on YouTube. So it's fantastic. Later on this, so that's September 18th. Later on this month, we've got a really cool event that would normally be this huge public outreach opportunity. But again, we're still living in this COVID world, and so it's going to fall into the virtual category. But Derek's got a really good friend, coworker that is at the U.S. Space and Rocket Center, and they've actually invited us to participate in their event. And so the plan is, weather permitting, is that we're going to have some live telescope views that night for International Observe the Moon Night. And people all over the country, if you're not here in Central Florida, look up your local astronomy group. I'm sure that there's probably plans for things going on, and you're going to see all sorts of fun stuff. But the moon is just one of the most spectacular things to look at with binoculars. It's spectacular to look at with just the naked eye, but when you can really study it in detail with the telescope, well, that's exactly what Derek's going to be able to bring you with some real fancy telescopes that we've got here at the college. And we'll be able to look at craters, mountains, craters inside of other craters, beautiful dunes. We'll be looking, I'm sure, at the landing areas, the mares from the Apollo missions. So lots of cool stuff. Write that date down on your calendar. Derek, you want to add anything else to that?
Yeah, so information about the event, we're actually, Justin and I will be meeting with my friend who works at the center next week, early next week. So we're firming up plans right now. So we don't have any information just yet about our, but check back with us. We'll be posting on our Facebook once we get all the information set in. So just keep tight for that.
Excellent. All right. Well, now we get into October. And October's got some pretty cool stuff happening. In 2016, NASA launched an asteroid sample mission called OSIRIS-REX. And OSIRIS-REX, the spacecraft, spent 2 years traveling to this asteroid Bennu, and spent another 2 years in orbit around the asteroid, surveying it, trying to understand exactly the makeup of this asteroid. And the diameter, it's about 1,600 feet, so about a quarter mile. It's not a small asteroid. It's a fairly good size asteroid, and it's traveling at about 63,000 miles per hour around the sun. So this spacecraft is going to land briefly on the asteroid, touch down on the surface, and it's going to gather about a 2-ounce sample of the surface, the dirt, the regolith of this asteroid. And this is NASA's first ever attempt at doing this. American spacecraft have never landed on an asteroid before. So the Japanese space agency, JAXA, has actually done this twice. Hayabusa 1 landed on asteroid Itogawa back in 2010. And then they did it again with Hayabusa 2 just in November of last year. And that sample is already on its way back to Earth. And it's going to land here back on Earth in December of this year. But OSIRIS-REX is going to be taking the sample in October and start bringing that back to Earth. But this is a carbonaceous asteroid. Derek, do you want to talk a little bit about what that is?
So carbonaceous asteroids contain organics. It contains silica, stuff that's found that makes planets like Earth. So when we collect samples from OSIRIS-REX, we can better understand how planets like our planet Earth have formed and how life could have originated. Lots of really cool stuff. We actually have samples of carbonaceous chondrite meteorites that come from these asteroids. And you know, when kids get to hold it, they get to hold some of the oldest stuff in the solar system. These are the oldest remnants in the solar system. Kind of like if you make cookies. I like cookies. Justin likes cookies. We all like cookies. Hopefully, everybody likes cookies. If you don't, boy, you're missing out. But when you make cookies, you might have some leftover stuff in the pot, right, or the bowl. That's what's left over. These are those asteroids, and we can get a better understanding of how planets like Earth and the terrestrial planets formed.
Yeah, very cool. So the primary sample site is Nightingale, and then the backup sample site selected is Osprey. So the touchdown is going to be happening on October 20th. So put this date down on your calendar. October 20th next month, we will be doing the first sample collection attempts. Now, they've done 2 rehearsals of this so far, and they both were very successful. But OSIRIS-REX, as it orbits around the asteroid, they'll actually use the thrusters of the spacecraft to briefly land on the asteroid and take that quick sample. They have what's called the TAGSAM arm, and the spacecraft won't literally land on the asteroid, but the arm will reach out, touch down on the surface briefly for 5-10 seconds, and it will blast nitrogen through these tubes that will collect the regolith and store it and bring it back here to Earth. And they've got 3 attempts that they can do of this. 3 attempts where that TAGSAM arm will be able to take the sample, bring it back to Earth, and that is scheduled to arrive in September of 2023. It's going to land in the Utah desert and just hopefully give scientists a whole new understanding of what's going on, these ancient billion-year-old leftover pieces of planets that didn't form. Another incredibly exciting launch is in October. A lot of cool stuff going on in October, but we've got we've got SpaceX's Crew 1 launch. So let's back up a little bit to kind of get to where we're at now. So back in March of 2019, which just seems like a lifetime ago, but that was the first DM uncrewed mission, DM1. It was an uncrewed mission of a kind of proof of concept. SpaceX was able to launch the rocket. It was able to autonomously dock with the International Space Station, and then it was able to autonomously undock and come back to Earth. DM2, which just happened earlier this year, this was the big one, right? This was Doug Hurley and Robert Behnken, 2 American astronauts that were on board this spacecraft. And on May 30th, 2020, SpaceX became the first private organization to send astronauts into space. This had only been done by government entities, so it was a pretty monumental flight. Well, now we are at Crew 1. And Crew 1, we're past the demo phase now. Crew 1 will be the first crewed operational flight. See, Doug and Bob were mainly kind of riders on board an autonomous vehicle. This will be the first one where these 4 astronauts will be piloting the spacecraft. And you've got 3 American astronauts, Shannon, Victor, and Mike, and then a Japanese astronaut that will be on board also. And these 4 astronauts will be heading to the International Space Station, and they actually have a pretty long mission there. They'll be there for about 215 days, doing standard operating procedures on the spacecraft, experiments, repairs, all the things that the astronauts are so amazing at. So get this one on your calendar, October 23rd, whether you're in Florida or not, you want to watch this. We're seeing American astronauts now on a regular cycle traveling to space rather than, well, paying the Soviet Union or Russia to send our astronauts up. So it's an early one. If you're up here in Florida, 5:47 a.m. Eastern, but it will be well worth getting up early for this one.
And we're keeping our fingers crossed because we applied to see this launch close up. So
I know.
Hopefully, if we get that access, we will be doing like we did with Perseverance. We will be live streaming the launch. So we're really excited. So yeah, everybody keep our fingers crossed. Hopefully, we'll get access to the launch.
Yes, I mean it's been a tough one because COVID has prevented us from being on site for a lot of these launches that we have been approved for, but they're very limited, obviously, on how many of the media they're allowing on site. So hopefully, I don't know, maybe we'll get lucky. But SpaceX isn't the only company in the launch queue here. We've got the CST-100 Starliner. This is a Boeing vehicle, and its maiden launch was in December of just 2019, and we were able to watch that from the Cape, and it was a good launch. It was a great launch, actually. The rocket did everything it needed to do by ULA. The spacecraft did everything it needed to do, but there was essentially a timing issue in the software, and that timing anomaly, unless your timing is absolutely perfect, and this is where they say it's rocket science, right? Unless your timing is absolutely perfect, even the slightest miscalculation, it prevented the spacecraft from timing perfectly to meet with the International Space Station. It did not reach the velocity that it needed to reach in order to meet the space station in its proper orbit. So it landed back on Earth. Everything worked there successfully, and it was actually the first ever capsule that made a land-based touchdown on Earth. In the past, capsules have always landed in the ocean, and even SpaceX's spacecraft land in the ocean. But the Starliner is designed to land on the Earth, and it will deploy these huge airbags and just kind of bounce and land on the terrain. So it landed in White Sands Missile Range, right, New Mexico, Derek, I believe. And so they're working on the software changes, and they're planning on having this ready to go probably by summer of next year. So we got SpaceX in the game sending astronauts. Boeing is not far behind. And then, well, we've got a new player in the game now. And if you're local to Florida, if you're local to Central Florida, you got to go check this building out. Blue Origin is a new spacecraft company that is owned and operated by Jeff Bezos. He's got some funds to do this, but this is a beautiful complex, and it's right across the street from the visitor center at Kennedy Space Center, right there in that complex. And this is where they'll actually be building the brand new New Glenn rockets. And they're actually building the launch pad right now. And this launch pad will be sending up this next generation of rockets. And Blue Origin is the next launch provider that is working on reusable rockets. SpaceX was the one to pioneer this, and Blue Origin is taking it a step further. What's amazing about the New Glenn is its size. I'm going to show you in the next image, which is going to show you New Shepard, which is the prototype. Then the Falcon Heavy, which is a big rocket. It's the largest rocket in operation right now until the SLS is ready. And then New Glenn. Look at the size of this thing. Now, the bottom half of that booster is completely reusable. The top half is the fairing that will hold heavy payloads. And this rocket right now is what's being built here in Central Florida. And they're already in the game. Blue Origin was selected by NASA to build one of the lunar landers called Blue Moon, and will be part of the Artemis project to actually land on the surface of the moon in 2024. Fingers crossed that's still on schedule. We've got some really exciting stuff coming up here over the next, in 2021, we will see this New Glenn hit the air. So you'll have SpaceX in regular rotation. We're probably going to see some initial flights of the NASA's SLS space launch system. We'll have Boeing sending astronauts to the International Space Station, and then we will have Blue Origin launching their rockets along with United Launch Alliance. So lots of really cool, exciting stuff going on right now. Lots of really cool stuff in the pipeline coming up. And tune in, keep tuning in with us. Every week we're going to be throwing out a new show on a new topic. And you can follow us on our Facebook page, our Instagram page. I didn't put our YouTube page on here, but I need to add that because, man, we're getting some good YouTube content started here, right?
Yeah, I mean, you just have to remember Seminole Planet for all of them. They're all the same. So if you know Seminole Planet for Facebook and Instagram, it's the same thing for YouTube. So.
Absolutely. And then the Central Florida Astronomical Society, if you've ever thought, if you're here in Central Florida and you've ever thought about getting into astronomy, getting into telescopes, well, look up CFAS, and we've got an amazing group. We meet once a month virtually right now, but once this pandemic's over, we've got fantastic star parties, events, and we just have a lot of fun. So with that kind of ends my portion. I'll end my screen share here, and we'll answer any last few questions.
I found out the information about the asteroid 2018 VP1 is the name of it, and unfortunately there's not a whole lot of information at the moment about where it will exactly be during that pass, but it's within about double the distance or so of double the distance of the Earth to the moon in its pass. So it's going to be zipping by close, but not too close. So there's no fears of that. But as far as its exact location, that information is a little harder to find. So hopefully when we get closer to that pass, we'll be able to share more information about it. All right. Well, Justin, do we have any last minute questions before we finish up tonight's program?
I think that's it. Yeah, unless you want to talk a little bit about what we got coming up next week.
Absolutely, yeah. So next week on Friday at 7 p.m., we're doing a cultural astronomy program called Fire Creation, the Maya. So we're going to look at the ancient Maya people in their connection with the cosmos. So we're going to look at the stories, the cosmology, history, mythology, and some interesting features. We'll be able to take a look at what they saw and what they interpreted of the night sky as well, because it's amazing how many cultures around the world had their view of the sky and how important it is for us to share those people's stories. And so we're going to be doing a lot more cultural programs, and we're going to be collaborating with other people in producing these programs that will be celebrating the human story of the cosmos. So we're really excited about doing that. Justin, we mentioned OSIRIS-REX, but we do have a program coming up on that. You want to talk about that?
Yes, absolutely. That one is the September 25th, I believe, right? That's in 2 weeks.
It's October 2nd, I believe.
The 2nd? Okay.
That Friday then, yeah.
Yeah, we're going to be going into OSIRIS-REX in a lot more detail. We're going to talk a little bit about the origin of the need for this type of a project. And a lot more detail about the mission itself. So if you're excited about that mission, you want to learn a little bit more about it, tune in for that episode, because we're going to be going in a lot more detail about, just think about where we're at now. as a technological society that that we can land on an asteroid traveling 63,000 miles per hour going around the sun and take a sample and bring it back to Earth. It's just absolutely incredible, the technology that how far we've come. So check out that episode. You'll really enjoy it.
And to add to that, Justin, we're actually going to have Dr. Humberto Campins joining us, who is one of the principal investigators of OSIRIS-REX. So he is one of the lead scientists investigating OSIRIS Bennu and the stuff that is going to be collected from OSIRIS-REX. So it's really going to be an exciting episode. And of course, you can find out all of our upcoming events on our Facebook page. Just go to the events area and be sure to join us for our programs. We're excited about bringing these programs to you, and we're going to continue doing this until hopefully eventually we're able to join in again and have you all come visit the planetarium in the future. But with that, I want to thank you all for joining us tonight for our Central Florida Nights program, and we look forward to seeing you again in the future. All right, take care, everybody. Have a good one.
Thank you. Thank you.